Hello. Today I'll be talking about the empirical risk minimization excess risk bound and the proof of it. So let's start with the notation. The notation I'll be using is f hat as the empirical minimizer, or the function that was empirically selected on the dataset sample. F star is the oracle model, or the best performing model across the whole distribution. The third and fourth terms represent the true risk and empirical risk, respectively. If this still the notation doesn't really make sense, please refer to my previous video where I'll be discussing that. So what is excess risk? Excess risk, as we can see in the term below, is just the true risk of the empirically selected model minus the true risk of the oracle model. So it's the difference. And what we want to do is try and find a bound for that. How we find that bound is using the add subtract trick. How it works is very profound, because to prove it, all we have to do is subtract something we know and immediately add it back up again. Because subtracting something and then adding that same thing again is just, it cancels out, it equals 0 and thus does nothing. That means we can safely subtract and immediately add back terms in the thing, and it would still be equal to the original excess risk. So we can see here that the excess risk is thus equal to the true risk of the empirical minimizer subtracted by the empirical risk of the empirical minimizer, and immediately add that back up again. Subtract that from the empirical risk of the oracle model, add it back up again, and finally we have our final one, which is the true risk of the oracle model. So far, it seems like this adding and subtracting, it does nothing, which quite literally, it doesn't really do much. But if we sort of group these terms into 3 groups, each group has 2 blocks in them, we can see a pattern emerging. We can see that term 1 is just the generalization gap, the difference between the empirical risk and the true risk, and that's for the empirical minimizer. Term 2 is just the difference between the empirical difference between the oracle model and the empirical model. And term 3 is the generalization gap for the oracle model. So seeing that we have 3 very interpretable terms here, what happens to term 2? So as we can see, term 2 is just the difference, the empirical difference of the risk with these 2 models. And by definition, the empirical minimizer is the model that minimizes the risk, the empirical risk, the most. That is, it makes it the smallest, and thus is the best one from an empirical risk point of view. Thus, the empirical risk of the empirical minimizer is always going to be less than or equal to the one of the oracle model, because by definition, it's the best one for minimizing the empirical risk. If we subtract these, because the empirical risk of the empirical minimizer is always going to be smaller or equal to, thus it's less than or equal to 0. If we want an upper bound, the worst case scenario, this would just equal to 0. And thus term 2, because it's 0, we can just drop it, because adding something to 0 just does nothing. So this is what happens when we've dropped that equation. But if you can see here, now we have we've changed the sign a bit from equals to less than or equal to, and we've added absolute values for term 1 and term 3. Why we do this is because of the triangle inequality, which states that the absolute value of a plus b plus c is always less than or equal to the absolute value of a plus the absolute value of b plus the absolute value of c. Because the original excess risk is always going to be non-negative, because the oracle model's true risk is always going to be smaller than the one of the empirical model, because by definition it's the best one, the one that minimizes the true risk. Because that term is going to be non-negative, we can apply that inequality right here. So how do we bound term 1 and term 3? First, consider the generalization gap, which is the difference between the empirical risk of a model and the true risk of a model. It's how much, how well it generalizes, or how much its skill set can basically translate to reality. In this case, we're taking the supremum of that, and if that's like the biggest possible one, and in this case, if we're taking this supremum of that, we're just trying to find the model, the value that has the biggest, the largest generalization gap, the worst case scenario. We're saying, if out of all possible models, which one is the worst case one, the worst possible one for generalizing. And in this case, term 1 and term 3 both satisfy this inequality, because nothing can be worse than the worst case. And because of this, we can thus substitute these terms into the equation again. And thus we get, this should say the less than or equal to. So the excess risk is thus less than or equal to the supremum of the worst case scenario added again. And because they're basically identical terms, we can sum them up, and thus it's 2 of that. So the excess risk is less than or equal to 2 times the worst case scenario of the generalization gap. So 2 times the supremum of the true risk minus the empirical risk.